Version 4.5 release is a major release, meaning that we have added some really exciting new features and functionalities to the software. But before going further, let's take a look on a couple practical things. So this recording of the webinar and webinar slides you can find from Delfoi extranet under partner news section. Then couple reminders. First of all, Delfoi extranet, it's for partners, it's for customers. We are putting there all the time new material like tutorials, manuals, sales and marketing material, evaluation packages for different products. And now there is also a link for the hotfixes. So meaning that between the official installers, if you have a problem, you might get a fix as a hotfix, and that this is the place where you download it. So basically, under Robotics customers, download 2 hotfixes, you end up to the hotfix site, where you have a download link for the hotfix installer, and then you can also read the release notes that what the hotfix basically is fixing. So meaning that if you find a new bug or some feature is not working correctly, or your customer is reporting this a bug to you, you can always take a look that, okay, would there be a hotfix already for this problem? If you don't find it, then contact our support. And then there is also a couple new bigger items like how to do offline programming on video, and then a few updated brand manuals and few also new ones. And then remember also that we have now our own folder in eCatalog, and we are adding all the time new material over there also. So now there is ready-made evaluation layouts for different products, arc welding, painting, surfax and so on. But there is also workpieces or components, fixtures, weld guns, etc. And let us know if you need something specific, so we can add those easily. Okay, but let's move on to Delfoi Robotics 4.5 release and its new features and functionalities. So first up is the localization feature, meaning that we now support languages that also Visual Components platform support. So it's English, French, German, Japanese, Korean, Spanish, Chinese and traditional Chinese. And how to change the language in the software is just go to File, Options and General, and then you can choose any language, restart the software, and a new language is set up. Then next new feature is a statement search functionality that allows you to search let's say statements by name or description, but you will see a live video from this how this really works. And then a new feature called undo redo. We have had lots of requests about this feature, that please add this one, and now we did it, and you can find it under path setup panel. So there is undo and redo buttons over there, and basically you can undo and redo any action you take on the path setup panel, but also you will see a live video of this in action. Then a new feature, maybe the biggest feature in the 4.5 release, it's called Program Validation Tool. You can find it from add-ons, Program Validation button, and basically it looks the same than the path check tool what you have maybe previously used, but now this is much more advanced tool. It allows you to basically check anything what you would typically do with the simulation. So it's kind of a background simulation done really fast, and it can handle basically any scenario, any layout type, including multi-robot layouts. And you will see a live video also about this one. Okay, so next up is my colleague Severi, who will show you in live how those new features work.
Hi all, Severi here. Now let's take a look at some of the new tools and features that we have added for the 4.5 release that will help you with your programming. Here we have a quite simple multi-robot layout where we have 2 welding robots and 1 workpiece positioner that act synchronously with the robots. The one on the right is the master and one on the left is the slave robot. And now let's create a simple program for this and then see what our new tools will do in this situation. So first let's create a simple program for the master robot. So let's create a new sequence over here and start to do some welds on the workpiece. First, let's do a weld here on the bottom side of the workpiece over there. And for the start point, let's also do an auto search. Let's also do 1 weld here on the other side, somewhere over there, for example. And let's also do a start point search with auto search for that one. Okay, now we have 4 statements for our first robot, and the first feature I want to demonstrate to you is the ability now to search for statements inside the program editor. So now these first 2 statements are here on the bottom side of the workpiece, so let's rename them both to be at the bottom. So we're just going to type in bottom at the name field of that statement, and then the next 2 we will write as top, so that they are at the top side of the workpiece, like this. Now we also have this statement search panel available at the top side of the program editor. Here we can open up the statement search on the right hand side, and here if we type in bottom, we can look for all of the statements that have the name bottom over here. We can also search for top, which will write all of the ones that have the name, or we can also search according to the identifier, which in this case for the first weld is W1. Note that also it will find the search that is now linked to weld 1 by the auto search automatically. So you can search for both of these statements automatically. You can also search for other statements. So for example, already in this layout we had a home point recorded. So if I write over here home, we can also see the home position easily, and also the program calls that call for the home program. So these will ease up a little bit the navigation inside your program. So for example, if you have hundreds and hundreds of welds in your program, you can name them accordingly for side A, side B, side, or something like that, and then use the statement search to find it. And when you have something that you found, for example the top weld, just double click on it and you will then end up in the path setup panel for that weld. The second new thing I want to highlight is that we now have the ability to do undo and redo actions when we modify these statements. So now, for example, if we go to a specific point in the weld and we do some changes, for example on the wire roll, now we can see that our statement has issues right after we have done some modifications. We have a singularity issue after we rotated it 15 degrees. Now we can also see that on the top side of the path setup panel, the undo button is now available, so we can cancel the last action that we did, and clicking that, it will cancel the recent action that you have done for the path. After doing one undo, it now allows you to also do the redo action, so it reverses the last undo action. And as many of these changes as you do, you can then undo and redo them all if necessary. So this will also help you with the management of your statements. If you do some irreversible change into your statement, you can now also undo it or redo it if you see that it was better. Now let's also take a look at the multi-robot programming. So now let's go to the slave robot and utilize those statements that we did for the master. So let's also create a sequence 1 over here. Let's select the master robot and the first 2 statements. Now over here we will select the first 2 from this position, and we're going to use the clone tool to mirror those statements so we can put them here on the left hand side into the similar feature that we have for the slave robot. Now we're going to also select the move path option. So we're going to select the target sequence to be the sequence 1 we just created. Component will be default, it is the same one where we create these. Target robot will now be the slave. Let's refresh that to sequence 1. And the base and tools, they will be at default. So now we're going to apply. And now all of these same statements will end up for the slave robot in this position. Also, let's do this for the last two. Let's move this one out of the way for now. Again, same settings, mirror clone, set the planes for the clone, see the preview that is okay. We're going to use the same options for the move and apply. And now also here on the slave robot we have the same program. Now the last thing for us to do is to get the statements synchronized between the robots. So now we're going to go to our search statement over here, and to do that we need to go to the path tab and set the sync status for each of these statements. So we're going to set for the master robot all statements the sync to be master. We're going to leave the positioner robot empty because our other robot, the slave robot, is now not a positioner, it is a welding robot. So we're going to keep this empty for now. These options under the path tab, they are available if you have the multi-robot option in your license. And to create synchronous, fully synchronous movement like this in Delfoi, you would need the multi-robot license to make it work. Then for the slave, it is more or less the same. We're just going to select slave robot to be the sync status, master robot will be the master, and then we're going to select for the first search also from the master robot. Then we're going to go and continue this for all of these other statements also. So slave, master, weld 1. Now for the second search is the same. We are a slave, master is the master, and in this case it will show you an error if you choose wrongly. So we're going to select the second search in the master robot. So there is basically no way you're going to do errors in this case. Again to the path, finalize the settings, and now we have our program synced and created. So we're gonna call our sequence 1 both on the slave and on the master like this. And now we can show you the final new tool that we have added, which we can find here from the add-ons right next to check paths. It is the program validation. So the program validation tool will check now for the program that we have created for all of the robots and all of the components involved. So here we can see 3 different columns over here. First one is for all of the robots, which will show the status of the combined situation for all of them. Then we have separately for slave and master robots. These positions are changeable, so we can switch the positions like this. We can also toggle them on and off if there are other robots in our layout that are not necessary for the program validation right now, but can be added later in some other phase of the program. Like with path check, we can also check for entire program, just one sequence or selected statements. And then of course we can select whether we want to check for joint limits, singularities and or collisions. And also now we have the option to select a maximum iteration step for the TCP while we run our program in the background. All the other options are the same as with the path check panel. Now we're going to check our entire program, so we're going to click on check, and what this will do is this will run the program in the background according to the TCP iteration step that we have allowed, and then it will check the entire program for collisions, reachability, singularities and so on. And after we have checked the entire program, we can then see the results in our program validation window like this. Now over here we can see where the problems happen. So as with path check, Now the green color indicates that everything is okay. On the top in all robots you can see the slider, which will then interpolate the program step by step, showing you the time where does the problems happen. And like previously, you can click on the color where you can go to the first problem point. So here we have a collision right over there with the slave robot and the workpiece. And now we can see also indicated here on the master robot side that the master robot program is okay so far. So now the approach movement for the slave robot would need some fixes, and like previously, when we go here into the problem point and we click on the statement where we have this collision, it will bring us right to the correct path setup panel of that respective statement. Then we can also go forward to see how the program looks and how it interpolates, and we can also see the full synchronized movement of all of the components that are taking part in the simulation. And there we can also see highlighted what are the problems we might have. So we have a collision now between the robots, and at the end we also have some issues with singularities when we approach the endpoints of these wells. And now after checking this path, we can be sure that this robot program is something that we cannot translate to the actual robot controller. There are quite a lot of issues that we need to fix, but this is a clear demonstration on what you can do with the program validation tool and how you can now easily check what is actually happening there with multiple robots in our layout, and how we can check for those and how we can fix those problems also. That's everything that I have for you today, so thank you for your attention.
Okay, so let's move on. So next we will show you a couple new search type we have added to 4.5 release. So there is now circle in and circle out searches, and these are now supported for OTC, ABB, Fanuc, Yaskawa and Panasonic robot brands. And then we have a small user interface update to make it easier to control how the path statement from visual components can be converted to Delfoi process path. And you will see also a live video about how this new user interface works. Then an exciting new feature, basically a 2D DXF drawing imported to Delfoi and converted to a Delfoi process path, and it's called DXF to path. And you can find it now in 4.5 release from templates DXF to path button over there. And next up is my colleague Vidisha, who will show you in live about how these new features work.
Hello all, Vidisha here. Let's now have a look at another set of tools for 4.5 release. We now support the circular searches for ABB, Yaskawa, Fanuc, OTC and Panasonic robot brands. And we will have a look in this layout how to generate those circular searches. I have already created two separate subroutines for inside search and outside search. So in this inside search, there is this circular seam already generated using the create path tool. And now we will move ahead and use the create search tool. After this, we go to the search mode and choose from here the 3D circ or 3D circular inside search option. And when I click on that, you will also see a preview of how you need to pick the touch points on the CAD file. So you can also see the notifications inside the output tab. So let's go closer and pick the first search surface as the center of the circle. Then pick the outside surface. And then the third surface would be the top surface where the seam is located here. And once you do that, you will see that this robot motion to calculate the circular searches is now generated. This has a little bit different way of tweaking these points that you have generated. So for instance, in this case, you would like to have these points to be touching a little bit on the top surface of these circle, and in order to do that you have these drive distance. So you can use this first block from here, the drive distance block, and when I change the length from here, you can see that the position on the vertical surface where these touch points are, I'm able to change that. Secondly, you can also change these point locations radially using the twist angle. So when I change these parameters in the first block over here, you are able to change the locations of these points radially. And another important thing is for this first touch point, for this height, you can tweak that point using the third row over here, so, or the third column. So if I uncheck this point, or if I uncheck the lock option, then I'm able to control the drive distance. Similarly, I'm able to control all of these other parameters from here using the third column. Next, you have some advanced parameters. These are specific to every robot brand. And based on the robot brand, these values will change. So in this case, you have the height first and variant options. And when you make a change to this option, so let's change the variant to 3. I will not be able to see the changes automatically. So in order to see the changes, what happens when you change this to variant 3, you might need to tweak something over here first. And you notice here that we have now a 4th touch location generated based on this variant. And now depending here, we just have a Delfoi robot model, but based on the robot brand that you're going to choose when you're going to create the search paths, you will see the differences in the search points that are generated when you change the variants in your layout. All right. And in the same way, we can also generate the outside search. So I have here outside theme generated. So let's click on the create search tool. And from the path setup tab, from the search mode, we will select the 3D circ outside search. Again, it shows the preview, how the search point should be picked up. I'll make just some changes to the drive distance. And let's go here and pick the first search surface, then the outside surface, and then the top surface. And once you do this, you have this search points for the search locations now generated. And then you can change the radial location using the twist angle. Also, if it happens so that when the robot is moving from the second touch location to the third touch location, if it is colliding between the workpiece, you can also use then the second row over here, which will then increase this wire distance along with the drive distance for the second and third touch points. All right. Also with this, you have the options, the advanced options for height first and variant. We did not see the height first option in the inside search. So let's check that. What it does, if I change this height first value to false, and again, we need to make some changes to the UI so that you can see the change of these height first visible. Now I will just again change this wire angle a little bit. And when I change this, let's make it 0. Notice that this height option has now changed to 4th. So the height detection is then done as a last point for the search. So that is basically the difference. Let's have a look at the path statement to process path tool. You can find this tool from add-ons over here. Note that this is only applicable to users having professional or premium version of the software. Now the usage of this tool could be for the cutting applications. So in case if you have a surface model with low thickness, it would be better to use the path statement tool from here. But one issue with the path statement tool is, let's see, that we have generated the path. but then you're not able to control all of these points together. You're not able to tweak them easily, as well as not able to add the process specific parameters to them. And to do that, you can use this tool from the add-ons, and you also have some options here in the UI to control the point generation. So once you click on the convert option, you see that this path statement has now been converted to this process path statement, and then you are free to use the path setup tab over here, all the options from here. And so you can also easily control the gantry so the points are reachable, and tweak the points however needed, and add the process specific parameters from here. Let's have a look at the DXF to path tool. This tool can be used mainly for cutting applications. So for example, if you have defined the process points for cutting operation in a 2D file, then you can import that 2D file so that the tool will automatically generate the robot motion points for you. So let's have a look at this, how to do it. Firstly, we will use the import geometry tool to get the 2D file. So select the 2D file and open in the software. We will then, using the move tool, snap this 2D file correctly on the CAD geometry. And once you have it positioned over here, you can use from the templates the DXF to path converter tool. In this UI, you have some options to control the distance and angle sensitivity for the circular points. Then you also have the option to remove the longest path. This means that if you have defined the outer boundary of the path inside the 2D file, and this is just for the reference so that you're able to easily place the 2D file on top of this CAD geometry, then you can remove that outer boundary of the path where you do not want to perform the cutting operation using the remove longest path option. Also, you have the auto split routine size. So for instance, in this case, after 200 points, the software will automatically create another subroutine for the process paths. So this is just to help you control the points inside a certain subroutine. Now, if we go ahead and click on the convert option, this is then going to convert the paths. So like here, you can see we have here all of these cutting operation paths generated, and then you can use the path setup tab to tweak these points however required.
Okay, so next up is a new statement for Delfoi paint product. It's called set brush, and it enables you to turn spray on and spray off between the standard motion points. Basically what you see here on the picture left here, that you have a standard motion points, and between those you can control when the spray is triggered on and when it's triggered off. And next functionality, it's a functionality update basically of conveyor sync. We had it already released in previous versions, but now we have modified it quite a bit how it works, and we will show you a live video how to operate with that one currently. And then a very cool, nice feature for Delfoi cut product called path offset tool. Here you see a couple pictures illustrating what was the problem in the current versions, what we have, and what is been how this helps you in the new 4.5 release. So if you take a look in here in this first picture here on the top left corner, you can see that we have created the path around the edges of this cutout. And then if you use current functionalities in Delfoi cut, giving some offsets from the wall, you might get this kind of a pattern where the calculation of the offsets is wrong. But now with these 2D offset paths, you can control how much you offset from the wall surfaces, and you can even repeat it for multiple times. And here you can see the final result, that now the offset is calculated basically correctly. But you will see also a live video how this works. And then a new functionality for Delfoi Surfx product called Recipes tool. It's let's say a little bit hard to explain in few words how it works, and you will see also a live video about this. But basically, it enables the operator to create a recipe how to get from rough surface to finished surface, for example, to the polished surface, by repeating the same surface paths, but just changing the abrasive what's been used on the tool. But you will see a video about this also in live. So next my colleague Tommy will take the control and show you how all these new functionalities work in live.
With Delfoi Paint, it's now possible to synchronize robot motion and conveyor motion together. In this layout, we have two robots painting a door that's moving on a conveyor. And it's missing the conveyor synchronization, but we will be adding it now. But it's just to show the movement, I press play, and we can see that the door moves and the robots just wait. And now that we want to have robot and the conveyor synchronized together, we create this conveyor sync statement. And you can see that it's able to take in other statements. And we have these parts already made. And I will move these all under the conveyor sync. And now it will need some parameters before it works. First of all, it needs conveyor and then sensor, which in this case is here. So this is the sensor that will trigger the execution of the conveyor synchronization statement. And we have to select the workpiece. I will select the door. And then we can set trigger offset. In this case, I will leave it at 0. And now, if I execute the program, it will actually wait for the trigger, and then it starts to execute the statements inside. I will pause here, and now if I select the conversion statement, it remembers where everything was when it started the execution. And now if I select any statement inside, it will again jump to that position. So now it's much easier to make modifications when we know where the workpiece was and where the robot was. Let's edit the second robot as well. It will also need to have conversion statement. I will move the only path here under the conversion. And again, I will put in the details here. But now we have to make or edit the trigger offset, because as you see, if it were to attempt to paint here, it would not be able to reach everything, and also it would collide with the first robot. To fix that, I will increase the trigger offset. I will make it a bit over 2 meters, and now the conveyor sync will actually wait for the trigger and this trigger offset distance before it starts to execute. You can see it from simulation that the trigger is now triggered and the first robot starts to execute immediately. But the second one will actually wait for the 2 meters to pass before it starts to do anything. Like so. And now we have simulated this. We could also post-process this and then upload to a robot. And it will also then do the same synchronization. So it will wait for the workpiece to arrive and wait for the trigger. And then if you set the trigger distance, it will also wait for that distance to pass before it starts to execute. 2D offset path is a new tool that can be used to offset an existing path. In this case, we have a cutout and then a path around it. To apply an offset to it, I will select the path and then I will go to add-ons and use the 2D offset path button. And it will open a new panel, and you will have to first select a plane. And this is the plane that the offset is done in. And now that I have a plane, we can see a preview of the offset. So it's 10 millimeters from the original path. I can change the offset, increase it, and I can actually flip it to the other side as well to expand this. And then if I shrink it enough, it will make it smaller and smaller until it will disappear. And you can see that in this case, before it completely disappears, we will get this scenario with two different islands, and they will be created as separate paths as well. And let's create 10 millimeter offset and create. And now this is the path that we got. If you want to repeat this offset for multiple times, it can be done in the same tool as well. So I will delete this and use the base path, and then let's apply the offset again. But in this case, I will increase the count. And now I create. And we get 10 millimeter offsets repeated. And you can see at the end, there are the islands as separate paths. Delfoi Surfax recipes can be used to manage complex programs involving multiple tool changes and also abrasive changes. In this case, we have two tools. There's a sander tool and then a spindle, and then we have two options for the abrasive for the sander. And then in the program editor, we have get tool, which contains all the necessary motions to get either of those tools, so either the sander or the spindle, and then also put tool to put them away, and then get abrasive to get an abrasive for the sander, and also putting away the abrasive. And then we have recipe source, which contains some via motions, how to get from station to another. And then I have already made a couple of processing paths, one for the sander and one for the spindle. And now the recipes, which can be found in the program editor, they are used to generate the program for a cell that already has this setup done. So the robot has to know how to get any tool or get an abrasive, and then how to move between those stations through via motions shown in here. So just a single point to move between stations. And then when we open a recipe, we can generate a program from it. And in this case, I have a two-step recipe, and each row is a single step. And one row defines a surface that's being targeted and the tool that is being used, and then some optional parameters. In this case, the sander will have a abrasive 100, and then pressure 300 and speed 75. And then after that, next step in the processing is targeting edges with the spindle and speed 50. And now if I press this create source routine, it will update this recipe source routine. And you can see that we now have folders which are empty, but essentially they tell us where to put our processing paths. So you can read at the top, and Sander and their path should be here. And I will drag and drop my Sander path under there. And then for the spindle, I will put it in the next. In this case, we have one path for each. We could have multiple paths for the same tool. This will demonstrate well the principle. And then when we are done with that, I can press generate, and it will create a program, and the program will be in the recipe output. Now this will contain steps based on the recipe. So there's 2 steps, and you can see that we also have 2 steps in the program, and under each step we have all the necessary tool changes and abrasive changes in a correct order to achieve this processing recipe. Now let's play this. We can see that it goes to fetch the sander first, and then for the sander it will get the abrasive 100. And then it will put away this paper, and then it will replace the tool with the spindle because it's the next one in the processing steps. And now we only essentially have to create once the setup for getting tools and putting them away, and then when we create those processing paths, we can use a recipe to tell the robot when to change tools. And now I can change the recipe. I can increase or make more steps. I duplicate the first one, and let's change the abrasive to a bit finer grit, and maybe change the pressure as well. And then I can reorder everything. Let's make the edges happen first, and then change the order of the sanding such that the order is now first edges with the spindle, then sander abrasive 100, and then sander abrasive 200. Generate. And now it will replace the existing program with the new one. And let's play. And we can see that the robot now takes the spindle first, and then goes after that to get the sander. And it will get the paper 100. And then it will change only the paper to 200, and then it will repeat the processing. So the recipes will make it possible to easily change the processing steps, and then just generate the program, and then the recipe generator will automatically handle the tool changes and abrasive changes in correct order. So you don't have to manually make those happen at the right times. And then let's take an example, one of the sander parts. And in the recipe, we can see that the first sander path uses pressure 300 and speed 75. And now let's look at the VPS tab for that path. We can see that it has 75 millimeters per second, and then also the pressure is set as a process parameter based on the recipe. And of course, you can then save the recipe and use it for different workpiece. Just you have to recreate or create the processing paths, but as long as the setup is done, you can just press generate, and it will do all the tool changes for you.
Okay, so then we have a couple more new things that's been added to 4.5 release. First up is that we have now 2 more post processors for Siasun and for Comal robot brands. Now in the partner release there are only downloaders, but we will add also basic uploaders to the commercial release, meaning that you can do calibrations and upload the calibration points, and maybe later we can improve the uploaders if needed. So then we have a new feature called Change Start, and basically it means that it's a tool for paths that are fully continuous around some shape. So it's not only for full circles but full loops. And if you're not happy where the start point is being calculated by Delfoi software, you can take basically any point from the path and say with change start that jump the points, the start point and end point to this location, and then basically it's rotating the path so that it's working as you want. And then we added also turn joint for joint 1 of the robot arm. So now you can control that if you want to force the joint 1 to be calculated over 180 degrees or less than minus 180 degrees. And where to trigger it is go to point control, and then you can control it on the column called turn J1. And then just to mention that we also added now default Yaskawa search jobs to the installer, and when you install the software you can find these default Yaskawa searches under this path over here.